Hi guys and welcome. Today's project is changing out a stepper motor. This is the old stepper motor of my machine. I brought this one here a few months ago with a view to changing it out and really only got around to doing it today. Despite the fact that the old motor looks bigger, it actually isn't. This is only a 150 ounce inch motor, whereas this one here is 270 ounce inch. I could have gone bigger, but I was able to buy this one here for the cost of the postage alone, trying to get the slightly bigger motor that matches the Gecko drive. This one is a good match for the Gecko drive, just has a little bit less power, that's all. The biggest problem that's delayed me in putting it in place is the fact that this motor here has an 8mm shaft on it. This motor here has a 1/4 inch shaft on it. Now I could have taken the old coupler and drilled that out to 8mm and away I go. But I decided I wouldn't do that. I want to keep this motor and coupler combination so that I've got a spare. Should this here ever go faulty, I've got a spare one I can just quickly swap out and I'm up and running again. If I simply bore this one here out to a bigger size, I then have to actually sit down and make a new one. So this video is going to detail how I make the new coupler and how I fit it back onto the machine. I hope you enjoy it. I'm using the old coupler to mark the length I require, and now I'll just use a parting tool on the lathe here to cut it just a little bit longer so I've got a little bit to play with. Acetal is just such great stuff to work with. It's quite a hard plastic. So next I'm going to just face off the edge here, so it's nice and square. Now that this edge is nice and square, I'm going to take an 8mm drill and drill it all the way through the block of acetal. I'd already started the end of my acetal with this here. This is a starting drill. It gives the cone for a center, and being very short and stiff, it also gives you a nice starting position. It doesn't wander when you start to drill. Since I've already put that in there, I don't actually need to do it again. So next, like I said, I'm just going to wind this drill all the way through the acetal. Right, now that my 8mm drill's gone all the way through, and I chose 8mm because that matches the diameter of the shaft on my stepper motor, I'm now going to run this 1/2 inch drill through, and I want it to go 38mm into the material here, and that is for the shaft of the lead screw to clamp to. So I've set up this depth clamp here to 38mm, and I'll be checking it periodically to make sure it hasn't gone in too far. Okay, so I'm only in 28mm. I've got another 10mm to go. To make my life a little bit easier now, I've gone and got a felt pen and I've marked from the edge of the flute there 38mm back this way and marked it here so I can see when I'm at the right depth. Well, that should now be 38mm, so I take my gauge, and yes it is. $38mm. So that's excellent. So the critical things here, where we need to drill our two holes, one after the other, without removing our stock from the lathe. That ensures that our two holes, our 8mm for the shaft of the motor and our 1/2 inch for the lead screw, are perfectly in alignment. Now that the holes have been drilled, I now need to machine the diameter of this here down a bit. So I've just got the calipers out and measure the diameter there and can start machining. Now, because this is the larger diameter, I can take it as far as I like, so long as I get to a point longer than I need. So that's fine. I only need to take it up to the jaws there. There we have it, the perfect size. I can check it for length, make sure it's definitely longer than it should be, so that's excellent. While it's there, I'll just give it a quick sand with a little bit of sandpaper. Break the edge here as well. We can now turn it end for end and look at machining down this face here, make sure it's square, and then machining it down to the smaller diameter here. My length looks good. I'll just quickly sand this edge here. just round over the edge here as well. And also just get rid of the sharp edge on there as well. And here we have it, a blank for our coupler. We now need to put some saw cuts in it to make it work right, so we can clamp it to our shaft, to our lead screw, and a saw cut through this way here to allow it to bend. So the next thing I need to do is put this saw cut through my blank here. And normally I do it with a hacksaw, but as the name implies, I usually end up hacking it. What I've decided to do this time is I've got a nice thin blade in the circular saw, and I've set the blade height so that the cut will just go through the small hole here and no more. And now I'm just taking two boards like so, put this in the center of my table here, two boards to hold it to stop it from moving around, and then I'm just going to put this on top and hold it down like this to ensure that it doesn't go anywhere when I run it through the circular saw. And there we have it, a beautiful saw cut through there. Looks very semi-professional. Next one I'm going to do is a saw cut through here. So this will allow me to clamp it around my shaft and my lead screw here. And as I said, the next one I want to do is one through here, and this will allow it to bend backwards and forwards this way. So the blade's going to have to be a little bit higher for this. I'm going to bring it up to about here. It should be halfway through the material, sorry. So, I'm just going to bring it up through here like so. And now I'm going to place the piece so that the saw cut here is at the bottom, like so, and I should just be able to run the saw straight through there to give me the cut I want. That's where it should be there. Now getting it lined up right, and we'll run it through. And there we have it, a beautiful saw cut through here. Now we should be able to just do a quick dry fit on this. This should now just slide nicely onto the shaft here, which it does. And the important thing is that the top of this is below the surface there, which again it is, so that's ideal. That's going to fit nicely. It's not going to bottom out on anything. So next I need to take the shaft and attach it to my motor. Again, that's a nice fit. I'll put on my clamps. I'm just using hose clamps, or Jubilee clips I think they might be called in other countries. And I'm just going to put it on so it's almost touching the body of the motor, but not quite. I want a little bit of separation, and then I can do up the clamp. So I've now got my clamps on the motor, and clamped around the shaft. That's not going to go anywhere in a hurry. I can now slide on this hose clamp like so and just drop it down into here, and we just push that down until it won't go any further. I can now take this hose clamp and tighten it up. The important thing here is that the shaft of my lead screw does not reach the top of my full cut, which it doesn't, so that means there is room for movement. You can see there that can actually move, and it can move relatively easily. Actually, I'll just loosen this off a little bit. Make sure this is pushed right down properly, because it is important that this... I'll leave that loose until I've got my bolts in. So now I can just push my bolts back in. My washer on. And my nut. I let the motor center itself in position, and then I tighten them down. Once I've done that, I was then able to tighten this piece here down. Now I can spin the motor, or spin the coupler there, and make sure it feels smooth, and it does. I'm not feeling any binding or anything, so everything looks like it's in alignment. Next thing to do is to connect up our wires. Right, so the first thing we need to do is we need to identify our coils on the motor, and here's a bit of a secret with stepper motors. If you short out a pair of wires, this is a 4-wire motor, so I'm only talking about 4-wire motors here. If you short out a pair of wires and the motor becomes hard to turn, which that isn't, then that's not a coil. Try the red and green. Oh yeah. Now I don't know if you can hear that, but you can hear a rumbling noise. So red and green are a coil. If I do the same for the blue and yellow, that's also a coil. If I short out the red and blue, for instance, it won't. That's not a coil. It moves a lot freer. So what I'm going to do now is I'm going to take off first 2 wires of my old stepper motor, and I'm going to just find the coils of it. I don't have a spec sheet for my old stepper motor, so I'm going to use the same process. That's nice and easy to turn, and by shorting those out, it becomes a hell of a lot harder to turn, and now it's easy again. So that's a coil. So I now know that this should be a coil, and that should be a coil. So I'll just take these off, and I can attach my new motor. So first up I need a coil, and I've forgotten which wires formed a coil, so again I'll just quickly test them. That's not. Is it red and green? Yep, yeah, red and green is a coil. So take my red wire, put it into here, and just tighten the screw up on it. And the same applies to the green. Oops. Okay, and now I can take the second coil there, short that out, definitely a coil winding, so I'm going to put the blue, and it doesn't matter which way around I get them, so long as I keep them within their pairs. You'll see on stepper motor specs, the coils are labelled A and B. You've got a positive A positive B, a negative A and a negative B. The two A's are a coil, the two B's are a coil. Now, it's important to keep the coils together, but it's not important which is the positive and which is the negative. Because having connected this up, I can now power up my stepper driver, and that should energize and lock up the motor. At the moment it's still running free, and then if I find that my stepper motor is running backwards to what I expect it to, I can either take this coil or this coil and reverse it. I only need to reverse the polarity of one of my coils and the motor will rotate in the opposite direction. Okay, so the moment of truth, I've powered it up and I'm now going to tell it to go up. And there we are, the motor's now going down. Tell it to go down and the motor's going up. Now I can just go into Mach 3 and change the direction it goes, but I'm actually going to do it here at the stepper motor. So I'm going to turn off the power to the stepper motor controller. And I'm going to just undo the first coil I come to. It doesn't matter which one it is. And I'm just going to swap the wires on it. So we can now power this back up. And we'll tell it to go down and up. There we have it. Easy way to replace a stepper motor on a machine without actually having to look up the specs of the wiring for the stepper motor. Of course, if you feel more comfortable doing that, I thoroughly recommend checking up the specs. But as you can see, it can actually be done with the most basic of tools. Simply shorting out a coil and checking whether the motor will turn, and that way you can easily identify individual coils on a stepper motor. So the last thing we need to do is we need to update this resistor to make it closer to the required current rating of my motor. I can either change it with a value that's correct, or I can add another resistor into here. They don't make resistors of the size, or at least I haven't got any resistors of the size I need, so I'm just going to add a second resistor in series with this one, which will bring it up to the value that I ultimately want. there we have it. I can now put my plug back together again, and we should have our motor running at full power. So once I changed out that resistor and put the plug back into the Gecko drive, I went a little bit further and just put this piece of sheathing here on the wires from the stepper motor just to keep them nice and tidy. I also doubled the speed of the stepper motor and ran a test file and found that it ran perfectly fine. Well, I hope you found this video interesting, and maybe one day you'll be able to use the information here to change out your own stepper motor or make your own coupler, maybe both. If you've enjoyed this video, please remember to like it. If you haven't already subscribed to my YouTube channel, please consider doing so. In the meantime, thanks for watching, and I'll catch you guys later. Cheers!